So today we will study inclusion exclusion principle and some applications of inclusion exclusion principle like derangement and towshed function. So what is inclusion exclusion principle? What is the idea behind this inclusion exclusion principle? In short, we will call it IEP, inclusion exclusion principle. Okay, IEP. So what is this IEP? This is a tool. Remember, this is a tool to find union of finite number of set. So you have finite number of set. Okay, like for example, union of 2 set, union of 3 set, union of 4 set. So this is a tool to find union of finite number of set. So for example, if you have 2 set, let's assume you have 2 set. Okay, you have 2 set A comma B. These 2 set you have. So this is set A, this is set B, and they can have something common. Now, if you want to find what is the union, like what is the number of elements in union, if you want to find that, then what that will be? What is the number of elements? Like what is the total number of elements here? So what that will be? That will be number of elements in A plus number of elements in B. Is this correct? Like if I do number of elements in A plus number of elements in B, is that correct? So no, that is not correct, because remember, let me call this area 1, let me call it area 2, let me call it area 3. Okay, so these are the area 1, area 2, area 3. These are the 3 area. Okay, now in this situation you can notice what we are counting here. What area we are counting here? We are counting all the elements of area 1, area 2. Okay, here we are counting all the elements of area 2, area 3. So this is your area 1, this is your area 1, this is your area 2, and this is your area 3. Okay, so like I can say that in this, when you do this number of elements in A, then you are counting the elements in area 1 comma 2. Here you are counting number of elements in area 2 comma 3. But you can notice these elements in this area. In this area, if you notice these elements, if you notice, so this area 2 is basically the A intersection B area. This is your area 2. So these elements in this area you have counted 2 times. How many times we should count? How many times we should count? So you have counted 2 times. You can notice 2 times you have counted all these elements of this area you have counted 2 times. So you will remove them 1 time. So number of elements in this intersection that you remove 1 time. Okay, so this is the idea. This is how you can find union of 2 set. Okay, number of elements in union of 2 set, that will be number of elements in set A plus number of elements in set B minus number of elements in A intersection B. Okay, this is your inclusion exclusion principle of 2 set. There are 2 set here. Do you remember this is called, this inclusion exclusion principle of 2 set? What this is called? Inclusion exclusion principle of 2 set. That is also called subtraction rule, if you remember. That is also called subtraction rule. Okay, so inclusion exclusion principle of 2 set, that we also call subtraction rule. So the idea is this: number of elements in A union B, that will be number of elements in A plus number of elements in B. But when you do this, then you have counted the intersection 2 times. So what you do, you remove the number of elements in intersection 1 time. Okay, now everything has been counted exactly 1 time. Now, because this is what this is the area which, this is the area 2. Now you can notice that now every area has been counted only 1 time. This area, this area, this area, area 1, area 2, area 3. Every area has been counted only 1 time. So this is the idea. Or you can understand like this: when you do this, remember, this is your area 1, this is your A, this is your B. Now when you do this, like number of elements in A plus number of elements in B, when you do this, then how many times this area has been counted? This area has been counted 1 time. This area has been counted 1 time. This area has been counted 2 times. Okay, so when you do this, then you have counted this area 2 times. Okay, so I can say this has been counted 1 time, this has been counted 1 time, and this has been counted 2 times. Now, so finally when you remove this, okay, finally this is your A, this is your B. Now from A plus B, when you remove the number of elements in intersection, now, okay, this is counted 1 time, this is counted 1 time, and now you have removed the elements. These elements you have removed 1 time. These elements you have removed 1 time. So now this area has been counted 1 time. Now every area has been counted 1 time. Okay, So this is the idea. Is this clear to everyone? So when you do this, then this intersection area you have counted 2 times. So you remove the number of elements in intersection. So now finally you have counted every element in this union. In this union, every element has been counted 1 time, and that is what we want. Okay, so this is the idea. Now let's move on. So this is the inclusion exclusion principle of 2 set. What will be the answer for this question? Let us consider a class in which you have 20 students. So there are 20 students who study algebra. So okay, and 25 students study probability and 8 students study both. Now how many students that study either algebra or probability? What that will be? How many students study either algebra or probability? So you can notice that this algebra and this is your probability. So how many students they study algebra? So number of students who study algebra, that is 20. Number of students who study probability, that is 25. Now number of students who study algebra and probability, that is 8. And the question is asking how many students they study either algebra or probability. How many students study either algebra or probability? So this, the question is asking this. So that will be basically number of elements in algebra plus number of elements in probability minus number of elements in both algebra and probability, because these elements have been counted 2 times. When you do this, then these elements have been counted twice. Okay, these 8 elements have been counted twice. These elements have been counted twice. So you remove these elements 1 time. So finally this will be your answer. Okay, you don't have to give the final answer. Don't worry about the final answer. This is the answer you should give, because this will tell us what is your thought process. Okay, in the combinatorics, in the GATE exam you should solve. In the GATE exam you should get the final answer, and when you are doing practice, then also you should get the final answer so that you can match. Okay, of course, see, sometimes you will apply the wrong method and you will get a wrong answer. But if you don't find the final answer, the final value you should find, so that you can check whether your answer is same or not. Okay, let's see. Let's move on. So this is the idea of inclusion exclusion of 2 set. What you are doing, you are including, this is called inclusion, yes or no? You are including all the elements of A and B, and then you are removing the duplicates. First you are including the elements of A comma B, then you are removing the duplicates. Okay, so that is the idea. Now let's solve this question. What will be the answer? Another very simple question. So tell me the answer now. In a discrete mathematics class, every student, already it is given that in a discrete mathematics class, every student is already given that every student is a major in computer science, or mathematics. Okay, or both. So every student in this discrete mathematics class, this is your discrete mathematics class. In this discrete mathematics class, basically every element is either a major in computer science or a major in mathematics. So this is your DM class. So DM, what is the number of elements in DM class? Can anyone tell me? Number of elements in discrete mathematics class. You can notice that every element, every student is either here or here or here. Every student is, okay, so I can say number of students in discrete mathematics class, that will be the number of students in the union. That will be number of students in the union. Okay, number of students having computer science major, number of students who have computer science, those are 25 students have computer science major, and number of students who have mathematics major, okay, those are 13. And the number of students majoring in both computer science and mathematics, the number of students in both computer science and mathematics, that will be 8. Now total how many students you have in the class? So in this class, total how many students we have? Because remember, it is already given that all the students are either here or here or here. This is already given in the first line. This is already given. Okay, so total number of students will be 25 plus 13 minus 8. Okay, so that will be the answer, and you can just calculate the answer. Final answer you can calculate. What is the meaning of this? Can anyone tell me what is the meaning of this? Possibly with computer science. Possibly with computer science. Mathematics possibly along with computer science. It simply means that these students, it simply means these students, see, these students have mathematics but not computer science. These students have mathematics but not computer science. These students have mathematics and computer science. So these students are mathematics student, and they may have computer science also, right? Is this clear? Okay, so this is the question. Now let's see one more thing. One more thing, some variations. You should take care. Some variations you should take care. Okay, don't blindly apply the formula. Do not blindly apply the formula. For example, if I ask you, what is the cardinality of A union B? What is the cardinality of A union B? Then you can also say that cardinality of A plus cardinality of B minus A. Is this correct? Is this correct? Tell me. This is A, this is B. So you can notice that this is number of students in A union B, and this is B minus A area. This is the area B minus A. So number of students in A union B, that will be number of students in A plus number of students in only B, plus only B. This means only B. This simply means only B, means not A, not in A, only in B. Okay, so this type of variation also they can ask. For example, they can also ask like this: A union B cardinality is equal to number of students who are only in A plus number of students are only in B. Is it correct? Is this correct? Number of students who are only in A plus number of students who are only in B plus number of students who are in A and B. Okay, this is correct now. Now this is correct. So like this also they can ask. This type of questions also they can ask. Okay, so this type of variations you can handle. Now let's see for three set inclusion exclusion principle. Okay, of three sets. If you have three set, then what will you do? So first you follow. Okay, let me create the diagram. So let's assume you have this diagram A, B, C. So this is set A, this is set B, this is set C. Now I want to find A union B union C. This is what I want to find: A union B union C. This is my question. Now tell me, if I directly do this, number of elements in A plus number of elements in B plus number of elements in C plus number of elements in C, then tell me this area how many times I have counted. Can anyone tell me this area how many times I counted? This area only one time. This area only one time. How many times this area I counted? See, these elements I only counted one time. These elements I only counted one time, because I am counting number of elements in A plus number of elements in B plus number of elements in C. This area, like, okay, only this much area. This much area, how many times I have counted? This much area, only this much area. See, this area I have counted in A and B. This area I have counted in A comma C. This area I have counted in A comma C. So this area I have counted two times. Okay, this area I have counted in C comma B. This area I have counted in B also. In B also. This area I have counted in C also. So this area I have counted two times. And this area I have counted in A also. This area I have counted in B also. So again, this area I have counted two times. And how many times this area I have counted? This area I have counted in A also, B also, C also. So this area has been counted total three times. Okay, total three times this area has been counted. Now what I will do? Now I will remove. Okay, let me remove. See, so basically, let me remove this intersection area. Means let me remove the area in A intersection B. Let me remove this area, A intersection B area. Now when I remove this area, means these elements, if I remove, means these elements, A intersection B is this area. This area is A intersection B. Then tell me how many times I have counted this area. This area now, how many times I have counted? Because I am removing this area, I am removing these elements. So when I remove these elements, then it means already it was 2. Now I have removed them one time. Now this will become 1 and this will become 2. This will become 1 and this will become 2. Agree? Yes or no? Very simple. Because this area was counted 3 times. Now you have removed it 1 time. This area was counted 2 times. This area was counted 2 times. Now you have removed it 1 time. Okay, so finally this is the concept now. Right now this is the concept. Okay, now what should I do? If I remove this B intersection C area, then what I will get? This B intersection C area, if I remove this B intersection C area, if I remove, then these count will decrease by 1 1. These two count will decrease by 1 1. This area I am removing. I am removing this area, so these counts will decrease by 1 1. Okay, so these two counts, they will decrease by 1 1. Okay, now what else? What else? Now if I remove A intersection C, if I remove A intersection C, this area I am removing. If I remove this area, then these two count will decrease by 1 1. These two count, they will decrease by 1 1. This will become 1 and this will become 0. Okay, is this correct answer? Did we get our answer? Okay, did we count? This is what we want. We want this. This is what we want. So did we count it? No. This area we should count one time, right? So I will add A intersection B intersection C. This area I will add. This area I will add. Okay. So this is your formula. Now everything has been counted. Now there is no problem. Now there is no problem. Now there is no problem. Is this clear to everyone? What we have done? Is this clear? This formula, the proof of this formula, very simple. So what we are doing, notice one thing, very nice thing you notice. When you find A union B, then what you do? Then you count number of elements in A plus number of elements in B, and then you remove the intersection, number of elements in intersection. Now similarly, if you count number of elements in A union B union C, then what you do? Then you first you count single. First you count single, means take them single. Then you remove their mutual interest, remove their intersection, A intersection B, B intersection C, and C intersection A. Then, because if you do this, then over counting. If you do this now, under counting, yes or no? If you do this over counting, if you do this under counting, now this is the perfect counting, A intersection B intersection C. So the idea is this: single plus, double minus, triple plus. Is this clear? Single plus, double minus. So like this. So this is the same thing will go for union of 4 set, union of 5 set. Whatever you do, the same thing will happen. Okay. So very simple. So plus minus, this will go on. For example, this is the idea. The same thing will happen. Single plus. If you have n elements, like if you have n set, if you have total n set, then single plus, double minus, triple plus. Okay, 4 minus, and so on. So this will go. Like for example, this is the example of 4 set. Inclusion exclusion principle with 4 set. These are the 4 set: A union B union C union D. Single plus, double minus, like all the double minus. Say single means A plus B plus C plus D. Then double minus means A intersection B, A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, and C intersection D. These are the double. Then triple, A intersection B intersection C, ABD, ACD, BCD, and then 4 minus. So basically alternative: plus minus, alternative: single plus, double minus, triple plus, 4 minus, 5 plus, 6 minus. Okay, alternative plus minus will go on. Now let's see few more interesting things. These things will help you in the set theory. These are related to set theory. Some small revision of set theory. I'm just revising the set theory. We have already seen these concepts we have already seen, but let's see them one time. Okay, so these are from the set theory and you already know them. So you answer. I will ask the question, you will answer it. So these are the areas. So let's assume these are the total. How many area we have? If you divide this in like mutually exclusive area, how many mutually exclusive area you will get? This is your universal set. This is your universal set. So how many mutually exclusive area you will get? Total 8. Total 8 area you will get. You will get 1, you will get 2, you will get 3, you will get 4, you will get 5, you will get 6, you will get 7, you will get 8. So total 8 area you will get. So here you can notice there are total 8 areas. In this, if you have 3 set, there are total 8 areas. How much area will be counted in A intersection B? In this A intersection B, how much area will be counted? 6,8 will be counted. I can say this is your 6 plus 8. Number of elements in A intersection B, that is number of elements in 6, number of elements in 8. Okay, tell me how much area this will count. Means how much area this A will count? That will count 2, 5, 6, 8. How much area this A minus B will count? How much area? This A minus B. From A, you remove the area of B, means only A. That is 2,5. Now, similarly, you can find what is A intersection B intersection C. How much area? That is your area number 8. Like if I ask you, A intersection B intersection C bar, means you should count A, you should count B, but you should not count C. Like who are taking algebra, biology, and this is your chemistry. So this means those students who are in algebra and biology, but not in chemistry. Those students who are in algebra and biology, but not in chemistry. These students are in biology and algebra. These students, they are in biology and algebra. They are in biology and algebra. Remove those, okay, but we don't want those students who are in chemistry. We don't want them who are in chemistry. So the answer will be area number 6. Okay, like this. So tell me, if I ask you, those students who are in algebra, but not in biology, not in chemistry. Those students who are in algebra, but not in biology, not in chemistry. So this means algebra. This means A. In A, it simply means in algebra, but not in. But means and. I told you this. But means and. This you already know. But means and. So, but not in biology and not in chemistry and not in chemistry. So they must be in A. They must be in algebra. They must be in algebra. From this, what you do, you remove those students who are in biology or in chemistry. So that will be only area 2. That will be area 2. Okay. So those students who are not in biology and not in chemistry, only in algebra. So this is the answer. So this area number 2. Okay, like this you can do. So whatever they ask you, if I ask you only B, if I ask you only B, only in B, then what will be the area? Only B, that means 3. If I ask you only C, then that will be 4, the area number 4. And if I ask you only in A or only in B, only in A or only in B, so that is 2,3. That is 2,3. These are only in A. These are only in B. Only in A or only in B. Now let's see how big or small is union of finitely many finite sets. So you have finitely many finite sets. Means every set is finite and number of set is finite. Finitely many finite set. So it means number of set is finite and every set is finite. So can anyone tell me, like what do you expect? What is the maximum value that can happen? A union B union C, what is the maximum value that can happen? What is the maximum value? What is the worst, like maximum value that you can get? Tell me, what is the maximum value you can get? And what is the minimum value you can get? So the maximum value you can get is number of elements in A plus number of elements in B. This is the maximum value you can get. This is the maximum value you can get. When this will happen? When this will happen, if and only if, when this will happen? When A intersection B are 5. Means when, if this basically A comma B disjoint. This will happen when they are disjoint. When A intersection B is 5. They are disjoint. Very simple. Okay, and what is the minimum value you can get? In A union B, what is the minimum value you can get? That will be maximum of cardinality A of A comma cardinality of B. This is the minimum value you can get. No, 0, no, don't say 0. This is the minimum value you can get. Minimum value will be maximum of A or B. That is the minimum value you can get. Yes or no? See, this will happen. When this will happen? This will happen if and only if one of them is subset of another. If and only if A is subset of B or B is subset of A. If and only if A is subset of B or B is a subset of A, then what will happen? Then this will happen. So the minimum value that you will get, is maximum of A comma B. Is it clear? Maximum of A comma B. For example, if you have B here, like B is a subset of A, then what will be the union? In this case, what will be A union B cardinality? That will be the cardinality of A. That will be the cardinality of A. Because you can notice maximum of cardinality of A or cardinality of. Is it clear to everyone? Tell me. So how big or small the union can be? The union can be biggest. This can be the biggest, and this will be the least. The union cardinality will be between them, between these two. Here A intersection B is B. In this scenario, A intersection B is B. So basically in this scenario, see, these are the two scenario. Not one. When A comma B intersection is 5, when A comma B intersection B is 5, अर्थात they are disjoint. It means they are disjoint. A comma B, they are disjoint. In this case, what will happen? Because they are disjoint, so number of elements in A comma B, A union B, that will be number of elements in A plus number of elements in B plus minus number of elements in A intersection B. What is the number of elements in A intersection B? That is 0, because A intersection B is 5. So number of elements in A intersection B is 0. So you can say number of elements will be number of, okay, so this will be the final answer. Another note you can take, what is that? When A is a subset of B, if A is subset of B, then what will happen? If A is subset of B, then what will happen? It means A intersection B is equal to A. That implies A intersection B is equal to A. Okay, and A intersection B is equal to A, that, okay, that is by implication. This is by implication. Anyway, now finally, what will be the cardinality of A union B? That will be the cardinality of A plus cardinality of B minus cardinality of A intersection B. Now the cardinality of A intersection B, that is same as cardinality of A. That is same as cardinality of A. This is your cardinality of A. So finally, this cardinality of A and this will remove. They will cancel. So finally, number of elements in B. Let's solve this question. How many integers from 1 to 40, both inclusive, are multiples of 6? How many integers are multiple of 6? So remember, this is your line, okay, and this is your 1, and this is your 40. Then what you will do? You want multiple of 6. So you can notice, basically you will go in 6, 6. So first, okay, the first multiple you will get here. The second multiple you will get here. The third multiple you will get here. Like this, you will keep going on like this. The last multiple you will get here. So basically you will jump by 6. Okay, you will keep jumping by 6. Just keep jumping by 6. Okay, keep jumping by 6. Then tell me how many numbers are multiple by 6. So that will be basically 6. Total 6 numbers are multiple by 6. But remember, it is like this. If you divide this 40 by 6, then what value you will get? See, we have from 1 to 40. From 1 to 40, you jump by 6. Jump by 6. Now, if I divide this, if I directly divide this 40 by 6, then some greater than 6 I will get, because this extra area we got. See, this extra area we got. So some value we will get, which is greater than or equal to 6. Like something like this. 6 point something I will get. 6 point something. This extra, why it is coming? Can anyone tell me? This extra, why it is coming? This is coming because of this extra area. Because of this extra area, this extra is coming. So to remove this extra, what I will do? I will find floor. I will do the floor. So 6 point something is there. I will find the floor, and that will be 6. Is it clear to everyone? So you jump by 6. Keep jumping by 6. Okay, but if I divide this 40 directly, if I divide this 40 by 6, then I will get something extra. That extra is coming because of this extra. There is some extra. Okay, so finally I will find the floor and I will get the answer. So remember, so this is the idea. The idea is very simple. From 1 to n, how many are divisible by b? This is your 1. Okay, this is your 1. So from 1 to n, from 1 to n, how many are divisible by b? So you will jump by b. You will keep jumping by b. You will keep jumping by b. Okay, you will keep jumping by b. Now, let's assume this is the last. Let us assume this is the last number which is divisible by b. Let us assume this is the last number divisible by b. Let us assume. Okay, like this you are jumping. So you are jumping and this is the last number divisible by b. Then because of this, now when I divide this n by b, then I will get the actual answer, okay, and the actual answer dot something extra. This extra I am getting because of this extra area. Because of this extra area, I am getting this extra. Okay, so what I will do, I will find the floor, x dot something. So the actual answer will be x. The actual answer will be x. So you can take the direct formula. The direct formula is from 1 to n, how many are divisible by b? That is floor of n by b. This is the direct formula, and this is important. This formula is very important. So remember, from 1 to n. Remember, from 1 to n, inclusive means including 1 comma n. From 1 to n inclusive, number of integers divisible by b. Number of integers divisible by b. That will be n divided by b floor. This will be the answer. N divided by b floor. Is this clear? From A to B, how will you find from A to B? From A to B, how will you find? The easiest method. I don't want to get into the aptitude. Okay, don't get into aptitude. Apply some smart method. Like, how will you find A to B? From A to B, how many numbers are multiple of n? So this is very easy. You already know. Let us assume from A to B. From A to B. So you already know this is your 1. Somewhere you have A, somewhere you have B. Okay, inclusive. How many? Inclusive. So now tell me, this is the hint. I have given you the hint. Now tell me the answer. How many numbers are, this is what I want. How many divisible? Like, how many are divisible by n? This is the hint I have given to you. So that is, okay, that is basically n by b, means from 1 to b, how many are divisible by b? Minus from a minus 1 to from 1 to a minus 1. From 1 to a minus 1. Okay, so this will be the answer. Is it clear to everyone? Is this clear? So basically this means from 1 to b, and this means from 1 to a minus 1. So very simple. See, I am asking you divisible by n. This is I am asking divisible by n. From 1 to a, how many are divisible by n? From 1 to a, that will be a divided by n. Okay, so that will be a divided by n floor. And from 1 to b, that will be b divided by n floor. What I want, this is from a to b. This is what I want. I want this. Then what I will do, from this, like total number of elements, total number of integers divisible by n, minus these integers which are divisible by n. Means from 1 to a minus 1. From 1 to a minus 1. Is this clear? Okay, is this point clear? Like this you can find from A to B. So very simple this. So finally the formula will be, if you want formula, then from A to B, how many are divisible by n? So the answer will be from 1 to B you find minus from 1 to A minus 1, from 1 to A minus 1. Very simple. So this is your final answer. This will be the final answer. Now let's see. Okay, so how many number of integers from 1 to n are are divisible by b? That will be n by b. Okay, because 1 to n divisible by b, inclusive. By default it is always inclusive. By default it is always inclusive. Remember this. Okay, by default it is always inclusive. By default it is always inclusive. So that is the by default. If they don't give you inclusive, means whether should I consider 1 comma n or no? Whether should I consider 1 comma n? Should I consider 1? Should I consider n? So that is by default inclusive. For inclusive, this formula will happen. For exclusive, this formula may give you wrong answer. This is inclusive, means from 1 to n, 1 comma n included. They are inclusive. Okay, so they are included, means inclusive. Means you are considering 1 also, you are considering n also. And similarly, what this will be, from A to B, multiples of n. So that will be from 1 to B, and from 1 to A minus 1. From 1 to B, from 1 to A minus 1. And the idea is like this. This is the idea. Okay, so let's solve this question. Tell me the answer. What will be the answer? How many integers from 1 to 100 are multiples of 2 or 3? From 1 to 100, how many numbers are multiple of 2 or 3? 2 or 3. So it means multiple of 2 or multiple of 3. How many are multiple of 2? That will be 100 divided by 2 floor. How many are multiple of 3? How many are multiple of 2? So that will be multiple of 2. That is 100 divided by 2 floor. How many are multiple of how many are multiple of 3? Multiple of 3. That will be 100 divided by 3 floor. That will be 33. And there is something extra. There is something extra you have done. So basically, these are divisible by 2. These are divisible by 2. These are divisible by 3. Okay. So divisible by 2, there are 50. Divisible by 3, there are 33. And what are these? What are common? What are these common? These are divisible by 6. These are divisible by 6, which is LCM of 2, 3. Because these are divisible by 2, 3. These must be divisible by 2, 3. So divisible by 2, 3, 2 and 3, 2 and 3, that is LCM. So this is your LCM. LCM is 6. So finally, okay, and how many are there? So how many are there? That is 100 divided by 6 floor. So what will be the answer? I think 16, right? So final answer will be, this 50 plus 33 minus 16. The answer will be 67. Tell me the answer for this. How many positive integers? The question is asking positive integer not exceeding 1000. What it means? Can anyone tell me? What is the range? From this, can you tell me what is the range? What is the range? Positive integer. Is it from 0 to 999? Or is it from 0 to 1000? Or is it from 1 to 1000? What is this range? Or is it from 1 to 999? Which range it is? Option A, B, C, D. Which range? Positive integer. It means this is wrong. It means this is wrong, this is wrong. Positive integer. Not exceeding 1000. It means this is correct. This is wrong. Not exceeding 1000 means it should not be greater than 1000. No, it should not exceed 1000. Okay, so this is the range from 1 to 1000. So this is the idea, from 1 to 1000. How many are divisible by 7? So these are divisible by 7. These are divisible by 11. And these common things, these are divisible by by LCM of 7, 11, which is 77. Okay, which is 77. So now you can find the answer. So very simply, you can find the answer. These are divisible by 7. From 1 to 1000, these many divisible by 7, these many divisible by 11, these many divisible by 77. The answer will be 220. This will be the answer. Now let's move on. What about this? How many integers from 1 to 100 that are neither multiple of 2 nor multiple of 9? I don't want multiple of 2. They should not be multiple of 2 neither nor multiple of 9. So now what should happen? So what I will do, from 1 to 100, basically total. This is what I will do. Total minus by 2 or by 9. Because I don't want anyone. Okay, I can say neither by 2 nor by 9. Neither by 2 nor by 9. So the answer will be total minus either by 2 or by 9. It is like this. The question is asking neither by 2 nor by 9. This is the question asking. The question is asking this. Not divisible by 2, not divisible by 2, and not divisible by 9. Not divisible by 2 and not divisible by 9. The question is asking like this. So you can apply the De Morgan law. That is, this is the answer. The answer is 2 union 9 complement. This is the answer. Okay, just apply the De Morgan law. So finally, this is your universal set. This basically means total, means universal set. Okay, minus 2 union 9. Okay, so this is the idea. So this is the idea. So total, how many you have? 1 through 100. So that is total is 100 minus divisible by 2 or by 9. So these many are divisible by 2 or 9. Minus these are divisible by both 2, 9. So that will be this. So quite simple. 100 minus these. So the answer will be 44. This will be your final answer. This is a question for 3 set. You have total 3 set. So a total of these many students have taken a course in Spanish. So the Spanish course that is given to you, that is 1232. These many people have taken Spanish course. Next, French course is taken by these many, and Russian course is taken by these many. And you can notice Spanish and French, that is taken by 103. That is taken by 103. And next, Spanish and Russian, that is taken by 23. Now you can notice that French and Russian, that is taken by 14. And these many students have taken at least one of these courses. So it means French, Union Russian, Union Spanish, that is 2092. This is given to you. Okay, so how many are taking this union? So that is given to you as like this. Now, how many students have taken all? And the question is asking F intersection R intersection S. So every data you have. So now you can find the answer will be F intersection R intersection S. That will be union minus. That will be union minus. Because the question is asking intersection. So that will be union minus single. Okay, from union you remove this 1032. You add double. You add these double you add. So means 103 plus 23 plus 14, and then you remove this only. Yeah. So this will be the answer. So answer will be like this. So this intersection, this will be basically this. You can just check it. Okay, very simple this, because already we know the formula. We know the formula like F union R union S. That will be F plus R plus S minus FR minus FS minus RS plus FRS. And the question is asking this. The question is asking me. So what you can do? You can just from this you can remove this and you can add them. So that is the answer. Let's solve this question. Quickly tell me the answer. How many strings of length 6 over the alphabet ABC start with C or a B? They should start with C or a B. So either they start with C or they start with B. Either they start with C or they start with B. So can anyone tell me this intersection? What is the cardinality of this intersection? How many elements we have here? Zero. Zero, right? So these are disjoint. This is zero. So these are disjoint. You can directly say. So the answer will be starting with C, length. Okay, starting with C. So this type of how many you have? How many you have for this type? That is 3 power 5 plus starting with B. That is also 3 power 5. So the answer will be 3 power 5 plus 3 power 5. Okay, twice. So that is 2 into 3 power 5. Okay, because already you are starting with B. Here you are starting with that. Next, what is the answer for this? Start with C or end with C. Either you start with C, either you start with C, or you end with C. Is there something common? So first you tell me end with C. What is the answer for that? That is 3 power 5. What is the answer for this? That is also 3 power 5. What is this common area? This common area is starting with C, ending with C. Starting with C, ending with C. This is the common area. So the 3 power 4, this is the common, 3 power 4. Okay, so the answer will be 2 into 3 power 5 minus 3 power 4. This will be the answer. So these are very simple questions from inclusion exclusion principle. What is the answer for this? Start with C and end with C. Start with C. Remember, it should start with C. And there are total how many positions? Total 6 positions. So 1, 2, 3, 4. And this end with C. So finally, answer will be for every position we have 3 choices. For every position we have 3 choices. So the answer will be 3 power 4. Tell me the answer for this. Let's see this. How many 5 card hands from a standard playing cards have exactly 1 king or exactly 1 queen or both? Exactly 1 king. So basically it means exactly 1 king or exactly 1 queen or both. This means here you have exactly 1 king and exactly 1 queen. So tell me the answer. Exactly 1 king. How many cards you can, how many 5 hand cards you want? You want 5 cards. You want 5 cards with exactly 1 king. With exactly 1 king. So first you select 1 king. Select 1 king, right? Yes or no? This is for 1 king. Select 1 king. There are 4 king. So select 1 king. This is for king. Okay, only exactly 1 king we want. So select 1 king. Remaining 4 cards we want. So from how many? Remaining four cards. Remaining 4 cards from 48. Because we want exactly 1 king. We don't want any other king. So 1 king we are getting. Then from the remaining we are getting 4 cards extra. Okay, so this is basically no king. Here we have no king. Next, the same answer you will get for 1 queen. Yes or no? The same answer you are getting for 1 queen. So 1 queen is also the same answer. First you select 1 queen. Then from the remaining cards, you select 4 cards where there is no queen. And what is the answer for this? 1 king and 1 queen. What will be the answer for this? 1 king and 1 queen. So first you select 1 king. Then you select 1 queen. Then from the remaining cards, you select 3 cards. From the remaining cards, you select 3 cards. So here you select king. Here you select king. Here you select queen. And this here you don't have king, you don't have queen. So what will be the answer? The answer will be, so the final answer will be twice multiplied by 4c1 into 48c4. Okay, this is your 1 king plus exactly 1 king plus exactly 1 queen minus when you have 1 king and 1 queen. When you have this, then the answer will be 4c1. You select 1 king, you select 1 queen, and from the remaining cards, you select 3 cards. Because total we want 5 cards. This is what we want total. To how many people this question is clear? Inclusion exclusion principle, very simple. Okay, let's see this. So tell me the answer. How many strings of length 6? You want length 6 from these alphabet A, B, C have at least 5 consecutive A's. At least 5 consecutive A's. Length 6, at least 5 consecutive A's. So you can do like this. See, you can do like this. Either this will happen, A. Either this will happen, right? Agree? Either this will happen or this will happen because you want 5 consecutive A. Either this will happen or this will happen. Anything else is possible? Anything else is possible? Is anything else possible? No, nothing else is possible. So are they exhaustive? Are they exhaustive? Are they covering all the possibilities? Yes, they are covering all the possibilities. Are they exclusive? They are exhaustive. They are exhaustive, but are they exclusive? So you can notice here in this question, you can notice A. Okay, this and A. So these two, if you notice, these are exhaustive. Yes, these are exhaustive, but these are not exclusive. So they are exhaustive. Every possibility has been counted. They are not exclusive, means duplicates counted. Some duplicates counted. You have counted some duplicates. So which duplicate you have counted? Which duplicate you are counting? This is the only duplicate you are counting, means they should start with 5 consecutive A and they should end with 5 consecutive A. So this duplicate you are counting. So this is 3, this is 3. Answer will be 3 plus 3 minus 1. Answer will be 5. Okay, very simple. Because remember, the common means it should start with 5 consecutive A. It should start with 5 consecutive A. It should end with 5 consecutive A. So the only possibility is this. In this question, you have all the data. You can take this question as homework. Every data is given. So there are total 1,000 people. They have symptom A, symptom B, symptom C. This is given. Symptom A and B is given. A and C is given. B and C is given. And this A intersection, B intersection, C is given. And the question is asking union. The question is asking union. Okay. So at least one symptom. Who is getting at least one symptom? So the complete data is given to you. From this, you can find the answer. Okay. Let's see this question. This is interesting. So tell me the answer for this question. So there are 7 people: mother, father, 2 sons, 3 sons, 2 daughters. How many lineups are there in which the mother is next to at least one of her son? Means mother is with her son. Okay, like maybe MS1 can be there, or maybe SM1 can be there, or maybe MS2 can be there, or maybe S2M can be there. So basically like this, the mother should be with at least one of her son in this photo. What do you think? What is coming to your mind? Can anyone tell me? What is your thought process when you see this question? What is coming to your mind? The first thing, what is coming to your mind? Tell me. Just tell me this point. Yes, fix mother. So this is the method number 1. Okay, let's fix mother. So you can create cases. Method number 1, you can create cases like, see, if mother is on the first position, you can create cases. Case 1, when mother is on the first position, then total how many positions remaining? Total 6 positions remaining. So this is the case when mother is in the first position. When mother is in the first position, what is the answer for this case? If mother is in the first position, okay, because lineup, so order matters. You are putting them in a line, so order matters. So if mother is in the first position, how many choices for the second position? How many choices for the second position? Only 3 choices. Daughter or father can come. 2 daughters, 1 father. 2 daughters, 1 father. They can come. They can come. After this, how many for these? Okay, this is done. Now, how many for this? Now the remaining people can go in 5 factorial ways. Yes or no? The remaining people can go in 5 factorial ways. Yes or no? Is this clear? So you are putting one person here. You are putting, for example, father, you are putting here. You are putting father here. Then the remaining people can arrange in 5 factorial ways. See what I'm doing in this method one. I am doing the complementary. I am doing the complementary process. Complementary method I am applying. Okay, I am applying the complementary method. So what basically I am saying that total minus mother not with her son, mother not with son, mother not with any son, mother not with any son. So I am applying the complementary method. Okay, so this is what I am doing. So the case one, I am applying the complementary method. Total minus mother not with her son, any son. Total you already know. What is total? Total is how much? 7 factorial. Total is 7 factorial. Okay, now I am finding mother is not with any son. So the case one, mother is in the first position. Case two, mother is in the last position. The same answer. For the case two also the answer will be same. The answer will be same 3 and 5 factorial. For this also answer will be same. Case 1 and case 2. They will give you the same answer. What is the case 3? What will be the case 3? Case 3 means that mother is in any of these positions, either here or here or here or here or here. So mother can be in any of these positions. 5 positions for mother. There are 5 positions for mother. There are 5 positions for mother. So these are for mother. Mother can be in any of these positions. Okay, let us assume mother is here. Let us assume mother is here. If mother is here, then what should happen? For this position, how many choices? 3 choices for this position. This position has 2 choices. The remaining 4 people can arrange in 4 factorial ways. The remaining 4 people. Okay, this is the mother. So on the left of the mother, 3 choices. 3 choices on the left of the mother. 2 choices on the right of the mother. The remaining 4 people can arrange in 4 factorial ways. So the answer will be what? Can anyone tell me? So from this method, answer will be 7 factorial minus 3 into minus 2 multiplied by 3 into 5 factorial plus 5 into 3 into 2 into 4 factorial. Okay, this will be your answer. Is this method clear? Complementary method. Anyone has any doubt in this method? Only three cases possible. Either mother is on the left hand, or mother is on the right hand, or mother is not on the end. So means mother can be in the 5 positions, not on left and not on the right hand. Mother is any of the 5 positions, any of the remaining 5 positions. Only 3 cases are possible. We have counted each 3 cases. Complementary method means mother is not with any of her son. So here you have total, and here these are the mother not with any son, mother not next to any son. Now, can you apply this inclusion exclusion principle? Method 2, can you apply this inclusion exclusion principle, IEP? Inclusion exclusion principle, can you apply? So what will you do? Basically what we want like mother is with S1, mother comma S1, or this is what we want. Yes or no? Mother is with S1, or mother is with S2, or mother is with S3. Yes or no? This is what we want. Yes or no? We want this or this or this. This is what we want. Mother with S1 or mother with S2 or mother with S3. This is what we want. Very simple. Very simple. So tell me, mother with S1 or S2. So the answer will be what? The answer will be mother with S1 plus when mother is with S2 plus when mother is with S3. Is it correct answer? Is this correct answer? No, because minus when mother is with S1 comma S2. when mother is with S1 comma S2, S1 comma S2, two positions S1 comma S2, minus when mother is with S1 comma S3, minus when mother is with S2 comma S3. Okay, and what we should do, plus, is it correct answer? Is this correct answer now? Mother with S1 plus mother with S2 minus mother with S3 minus this, plus what should I do? Mother with S1 S2 S3, that is not possible, right? That is not possible. Mother with S1 S2 S3, that cannot possible, that is not possible. Is this clear? That is not possible. See, this case is not possible. Like mother, only two possible. Okay, like S1 S2 S3, this is a 0, this is 0, or I can say this is not possible. So this third case is not possible at all. Mother with S1 S2 S3, that is not possible. It is not possible. So now you find the answer. These three are same, so I can say 3 multiplied by these three are same, so 3 multiplied by mother is with S1. Just find out this, and these three will be same. So how many where mother is with S1? Like mother is with S1, how many? So when mother is with S1, it means you put them in a box. You put them in a box. So finally it's like this: mother is with S1, then there is S2, there is S3, there is father, there is daughter 1, there is daughter 2. So finally that will be 1, 2, 3, 4, 5, 6. So that will be 6 factorial. Is it correct? Is this correct? Multiplied by 2, because these two can arrange in 2 factorial ways. Multiplied by 2. So the answer will be 3 multiplied by 6 factorial into 2. 6 factorial into 2 minus these three will be same. These three will be same. Here these three will be same. So here I can say minus 3 multiplied by mother is with S1 comma S2, like mother with S1 comma S2. So how many possibilities for that? Mother with S1 comma S2, like this is the idea. Mother is with S1 comma S2. So you put them in box, M S1 S2, you put them in a box. The remaining is S3 F D1 D2. So that will be 5 factorial multiplied by how many for them? How many for them? Only 2. Only 2, because remember, mother should be in the middle. Mother should be in the middle. So only 2. So that will be 5 factorial into 2. This will be your answer. Is this clear? Anyone has any doubt in this? Inclusion exclusion principle. So these are some applications. These are some questions. This question you can take as homework. Okay, the answer is here. So you can check the answer. For this question, you can check the answer. Answer is this. And this question you can take as homework. So these are similar questions like this. This is your family lineup. Family lineup, this type of similar question you have. Line up a family, line up a family. This type of questions are there. So now tell me the answer for this question. How many strings of length 6 over A, B, C, D, E have at least 4 consecutive edges? Have at least 4 consecutive edges. So what is going to be the answer? At least 4 consecutive edges. So where can be these edges? See, there will be like this. There will be 3 sets. S1 will be like this. Total length 4 we want. We want total length 4. Length 6 we want. So either this can happen. Either this can happen because we want 4 consecutive edges. We want 4 consecutive edges. Either this can happen or this can happen. Yes or no? Agree? Are they covering all the possibilities? Are they covering all the possibilities? They are exhaustive. They are exhaustive, but not exclusive. But not exclusive. They are exhaustive, but not exclusive. They are covering all the possibilities. So tell me the answer. Basically, what we want, We want S1 union S2 union S3. This is what we want. So what that will be? That will be S1 union S2 union S3. That will be, remember, that will be this and this. These are same. I can say these are same. So I can say 3 multiplied by, remember, this S1 plus S2 plus S3. These are same. This will give you the same answer as this. So S1 is basically, S1 is 5 choices here, 5 choices here. So S1 is 5 square. S2 is also 5 square. S3 is also 5 square. Minus, okay, minus double 3C2, because there will be 3C2, or I can say 3. Okay, S1 intersection S2. So this is like SI. This is for SI. And here what you will have, this is for SI intersection SJ. SI intersection SJ. But there is a problem here. No. This is not okay. This is this correct? Can I say they will be same? See, all the SI will be same, but can I say SI intersection SJ will be same? No, those will not be same. Because remember, those will not be same, because what is SI intersection S1 intersection S2? What will be that cardinality? S1 intersection S2 cardinality. What will be that? S1 intersection S2 means common, between these common. So that is only one position will be left. Only one position will be left. So this will be 5. Okay, and what is S1 intersection S3? What is that? S1 intersection S3. S1 intersection S3. What is that? That is only 1. That is only 1. Minus S2 intersection S3. Minus S2 intersection S3. What is that? S2 intersection S3. What is that? That will be again 5. And plus S1 intersection S2 intersection S3. That will be 1. Okay. So this will be the answer. Is this clear to everyone? So total how many will be there? This will be your answer. Okay. 3 into 5 square minus 5 minus 1 minus 5 plus 1. Similarly, you can do this question. Okay, just take it as a homework. From 1 to 40, how many are divisible by 3 or 7 or 2? Okay, so this is a simple question. Divisible by 2 or 3 or 7. And this is a question for inclusion exclusion principle with 4 set. So tell me the answer quickly. Take the copy pen and tell me the answer. Complete detail is given to you. Complete detail. Each set has 15 elements. Every set has 15 elements. The pairwise intersection has 5 elements each. The three-way intersection has 2 elements each. And there is only one element which is in intersection of all of them. So what will be the answer? So what is the answer for size of union? So that will be, remember, every set has 15 elements. Total 4 set you have. So that will be 4 into 15 minus double. How many double you have? Every pairwise intersection has 5 elements. How many double you have? Can anyone tell me? So pairwise means 4C2. There are 4 set, 4C2 multiplied by 5. Double, okay, minus, plus, triple plus. So that is 4C3. You select 3 and everything has 2 elements, minus. Then this 4C4. Okay, so only one element in the intersection of all of them. So this plus minus this, and only one element. So this will be the answer. So this is going to be your answer. Is this clear? So basically the answer is 60 minus, this is 6 and 5, that is 30, plus this is 4C1, that is 4, so that is 8, minus 1. So this is the answer. So 30 plus 7, so answer will be 37. How many 5 card hands have at least one ace or at least one queen? So basically there must be at least one ace, there must be at least one ace or at least one queen, greater than or equal to one queen. So what is this? Can anyone tell me what is the common? Either we want this or we want this, either we want this or this. So what is common? Common means at least one ace and at least one queen. Okay, that is at least one ace and at least one queen, because this is the idea. At least one ace greater than or equal to one ace, or greater than equal to, so I can say one queen. So this is the idea. Now tell me, like at least one ace, what will be the answer for this? At least one ace. At least one ace. What is the answer for this? You should select at least one ace. What will be the answer for this? Is it correct? Like if I do, is this correct? If I do from four ace, I select one ace, and then from the remaining cards I select four cards. Is it correct method? Is this correct? Why this is not correct? Can anyone tell me why this is not correct? I am selecting one ace, at least one ace I want, at least one ace I want. I am selecting one ace, then I am selecting remaining four cards. Do you remember which mistake is this? Do you remember which mistake is this? On the private group also, on our Go classes private group also, some students are making this mistake, right? And whenever someone is making this mistake, then a lot of people, they reply most common mistake, most common mistake. So basically this is your most common mistake. I told you about this most common mistake. Okay, because what you are doing, see, this is reserved for ace. This is reserved for ace. You are reserving this for ace. You are reserved. This is reserved for ace. Now here you are allowing ace. Here you are again allowing ace. So that is the problem. This is the most common mistake. So this is wrong. So this thing is wrong. Okay, now, so what should be the correct answer? The correct answer will be at least one ace means total. Okay, like you have total means 52 C5 minus when you don't have ace, so 42 C5 means, okay, this is correct. From total you remove when you don't have any ace. You don't have any ace. Similarly, at least one queen. What that will be? What that will be? Same 52 C5 total minus when you don't have queen. When you don't have queen, okay, minus this will be minus. What it will be? It will be total. It will be total minus. So when there is no ace, you remove. When there is no queen, you remove. So there is no queen, you remove. There is no ace, you remove. So from total, you are removing when there is no ace. You are removing when there is no queen. What else should I do? You are removing when there is no ace. You are removing when there is no queen. What else should I do? I should add when there is no ace and there is no queen. When there is no ace and there is no queen, 44 C5. Yes or no? This here, we don't have any ace. There is no ace. There is no queen. There is no ace. There is no queen. But you should add when there is no ace, there is no queen, because this you have counted here also. You have removed here also. When there is no ace and there is no queen, this you have removed here also, here also. So what you should do? So you should add it. So finally answer will be this plus this minus this. Okay, you can basically, many terms will cancel out. Many terms are going to cancel. Is it clear? Actually, this question we can very easily solve, actually, because you are asking at least one ace or at least one queen. So what you can do that from total you can remove when there is no ace, and there is no queen. This is what you can do. Actually, simply we can do this. Yes or no? From total you can directly remove when there is no ace and there is no queen. Yes or no? When there is no ace, when there is no queen, this you can remove. Now total you have 52 C5. From this you can remove when there is no ace and there is no queen. So that will be 44 C5. So actually, if you notice, this we don't have to do. We don't have to do this. We can just directly do. Ultimately, all will cancel out. Actually, if you see, they will cancel out, and then finally you will get this. But this is the best method. This is the best method because you want at least one ace or at least one queen you want. Okay, either this. So I can say total minus there is no ace and there is no queen. So this is much easier. So it's like you want A union B. This is what you want. Then what you can do? You can do total minus neither this nor this. This you can remove, right? So this is your A. This is your B. You want at least this or this. Then I can say that it will be from total you remove when you don't have A and don't have B. Means not in A and not in B. So this area you remove basically. Yes or no? This is the idea. This area, if you notice, this area is neither in A and nor in B. So this area you are removing from total, from universal set. You remove this area, then you will get this cardinal. Is it clear? So this is what we are using. So you can use this also. So you can just write this in your note that sometimes you can use this also. A union B if you want. Then sometimes you can do total minus neither A and nor B. Like for example here, no ace and no queen. So like this you can do, and both are same because this is your area of A bar intersection B bar. Is this clear? Tell me. So this is actually you can take as note because this will help you sometimes. This you can take as note.